Let us see what are the applications of Newton's second law of motion. We know Newton's second law of motion, that is the rate of change of momentum of an object is proportional to the applied unbalanced force in the direction of force. That is, we can write force is proportional to rate of change of momentum. What is rate of change of momentum? It is change in momentum divided by time. Therefore, Newton's second law we can write force is proportional to change in momentum divided by time. The use of proportionality sign, it's already explained in the last class. You know, when a quantity comes in the numerator of a proportionality relation, it means when the first quantity increases, the second quantity also increases. Here change in momentum is in the numerator. Therefore, when change in momentum increases, force is increased. Similarly, since time is in the denominator, when time is increased, force is decreased. That is the use of proportionality relations. So, if we take separately, what is the dependence of time? When time is increased, force is decreased. When time is more, force is less. So, let us write the dependence of time only like this. Force is proportional to 1 by time. That is, if we write the dependence of time only, we can write like this. Force is proportional to 1 by time. Or F is proportional to 1 by t. That is, when time is more, force is less. It means that when time required to change the momentum is more, force is less. Now let us see the applications of Newton's second law of motion. First one, a cricket player lowers his hands while catching a ball. You may have seen this one, that is, whenever a cricket player catches a ball, he will gradually move his hands backward, or he will gradually lower his hands. Why he is doing like this? We know according to second law of motion, F is proportional to 1 by t. That is, when time is increased, force is decreased. Actually, he is doing like this to increase the time to stop the ball. When he lowers his hands, the time to stop the ball is increased. So, the force is decreased. That is, the force on hands decreased, and he will feel only lesser pain. A person falling from certain height on cemented floor gets injured more, while a person falling from same height on heap of sand gets less injured. Why a person falling on a heap of sand gets less injured? You know, in that case, the person comes to stop taking more time. When fallen on the heap of sand, he will come to stop after going into a deep, that is taking more time. So, by Newton's second law, when time is increased, force is decreased, and he will feel only lesser pain. But when he falls on a cemented floor, he comes to stop suddenly. That is, time is decreased. Here he is taking only lesser time, means force will be more. Therefore, he will feel more pain and get injured. The same idea we can use in the case of all the applications. And next application is automobiles are provided with the shockers. And you have seen this one, shockers are used in automobiles. When shockers are used, the time of jerk is increased. Therefore, the force on body decreases and its journey is more comfortable. When one boxer punches other boxer, then the other boxer moves his head back. This also done to increase the time. When the time is increased, force is decreased and the depth of injury will be less. A karate player can break a pile of tiles with a single blow of his hands. Here, actually, he is moving his hands very fastly and he is hitting the pile of tiles suddenly. That is, he is taking only lesser time. Since the time is less, the force will be very more. That is why he is able to break the tiles easily.